weekend at the lake. And the boats on their trailers are faster than the trucks that tow them. There's more than one way to fly on water. These small powerboats don't have hydrofoils mounted below the waterline. Greg Terzian and his friends equip their toys with the most powerful motors they can handle.
These boats combine ultra-lightweight and advanced composite materials with high-technology engines that are producing massive amounts of horsepower.
Sheer power alone isn't enough to overcome the viscous drag of water. But when a boat's hull is designed to minimize the area in contact with the lake's surface, then the only limit to how fast it can go is the courage of the driver.
This is not the hobby or the sport for the everyday person. It's very, very dangerous to the amateur boater. These boats are set up and designed for the specific driver in mind. Each driver has tuned these boats to their own skill and their own preference. This is not a recreational boat. They are potentially deadly machines if not used professionally.
Basic solution is to design what's called a planing hull. A planing hull is like a skimming hull. That means to say when you put enough power on, if it's flat enough underneath, it starts to behave like skimming stone. You know, when you skim a stone across the surface, obviously the stone's not floating, but it's staying on the surface because the speed of it traveling over the surface is keeping it upright. Now that's the normal solution for going fast on a small boat.
This is probably the fastest 19-foot 4-seat boat in the country.
The ratio of power to weight is on the cutting edge of sanity. 300 horses pushing a shell that weighs only 310 kilos. Less than 3 well-fed men.
We're not just applying a massive amount of horsepower to something and hoping it goes fast. Although we are applying a massive amount of horsepower to something, we're using that horsepower very efficiently. That enables this boat to reach speeds upwards of about 130 miles an hour.
These drivers understand the crucial ratio between engine power and hull design. At top speed, the hull area that is contacting the water is reduced to just a few square centimeters. There is almost zero drag on the mainframe, but the trade-off is an almost total loss of steering and balance.
The power blade, and here, from this part of the lower unit and below, is the only thing that's going to be in the water. This part of the lower unit is known as the skeg. All outboard engines have it. And this boat is running over 100 miles an hour, and we're essentially flying over water. This piece right over here, skeg, is basically the only thing that's keeping us on an even keel on the water. Think of it as the compensation that the tail rotor of a helicopter provides to prevent the helicopter from spinning around. That's essentially what this piece does right here. The propeller, running this high out of the water, is going to want to have what's known as a paddle wheel effect, where it's going to want to walk across the water. Since it's not completely submerged, the forces are not equalized on the propeller, so therefore it's going to want to walk across the water.
The most radical hull design for extreme runabouts is called the V-bottom. When it goes on plane, only one tiny point remains in the water.
This is known as a stepped V-pad. This is a V-bottom design. This boat does not use air pressure for lift. It uses hydraulic pressure. In other words, hydraulic pressure is built up on the center sponson on this boat. The driver must balance the boat on that pad right there, which is roughly 7 inches wide. It makes for a very difficult boat to master the operation of, also very potentially dangerous for someone who's inexperienced operating this boat at very high speeds.
Driving a V-bottom at this speed is a tightrope act with no net.
The V-bottom boat requires hair trigger reflexes of the driver, and it is a wild, wicked ride.
a bit more stable to drive. Its lift depends on the flow of air through a series of pontoons or sponsons.
Here is a full tunnel. You'll notice this boat uses air pressure to gain lift, increasing air compression towards the stern of the boat as it packs air through its sponsons. Sponson depth is equal length. This boat, all three sponsons are in contact with the water at all times, making this boat very, very stable and predictable at high speeds. The bottom is made of special laminates and composite materials that are designed to handle the shearing forces of water at that kind of speed. At speeds above 100 miles an hour, normal fiberglass laminates just will not suffice. The water basically just wants to tear apart and shear off anything at that speed, because water is very much like concrete at those kinds of speeds, so you have to use special materials, and the design, of course, is a key component in how these boats handle as well.
As air blasts through the tunnel, the driver has to continually adjust the boat's trim, the angle at which the propeller meets the water.
These high-performance engines are equipped with hydraulic trim cylinders, basically controlled by this actuator right here, up and down. A very critical adjustment, which affects many dynamics of how the boat is operated in the water. The driver is always paying attention to this control and constantly using it to adjust the angle of the boat. The higher you trim the engine, the more it elevates the boat out of the water. You don't want to go too much because you're running the boat too loose, and then you could lose control. If you have the engine trimmed in too much, you get too much adhesion with the water and you could lose speed.
As air pressure builds up under the keel, the boat rises even higher out of the water. If you feel in control, that means you're not going fast enough.
Triad geo.orig intimidating drag boat, designed exclusively for maximum acceleration and velocity at the end of the quarter mile. This boat will push you back to the end of your seat. It's capable of running 10-second quarter miles.
The Triad is a hybrid of the tunnel and V-bottom designs, with a top speed of more than 180 kilometers per hour. It combines rush, risk, and roar.
Outer sponsons are higher than the center pod. This boat gets its lift by air pressure. The outer sponsons will assist in lifting the boat at the beginning of the drag course. As this boat gains momentum, these sponsons will rise out of the water, and air pressure will basically support and lift the rest of the boat while the center sponson maintains stability. To put it in perspective, this boat is capable of speeds that would basically embarrass any street rod on the road. But this boat does it on water. You'll never see a boat like this on the average lake. In fact, there is as much of a chance of seeing one of these boats in your average lake as you do seeing a Formula One car on your average street.